So it's my pleasure to introduce the moderator for our next panel. Our next moderator is Ms. Kate Greenberg, Colorado Commissioner of Agriculture. Commissioner Greenberg was appointed to this role by Governor Polis in 2018 and has the distinction of being Colorado's first female agricultural commissioner. So please welcome Commissioner Greenberg.
All right, good morning, everybody. Well, thank you, Steve, for the introduction. Thank you to Elaine and everybody who helped put on this event here today. It's great being in my home basin here in the Southwest, and welcome you all who are coming from far away. Just last month, my team and I were actually in the room next door meeting with Chairman Baker and Vice Chairwoman Cloud, members of the Tribal Council and staff for CDA's first ever tribal consultation. And that was really a pivotal moment in my mind for what our partnership with CDA and with tribal government looks like. And that relates so much to what Commissioner Mitchell and the former panel were just discussing. So before we jump into our panel, I just want to give a quick kind of update, background on the work that we have going on at the Colorado Department of Ag, and I hope you see how it ties in to all of the work that this wonderful panel up here today is going to be talking about. So at CDA, at Colorado Department of Ag, we have a lot of responsibilities for the day-to-day. If you have livestock, we're responsible for brand inspection. If you buy groceries at the grocery store, we're responsible for making sure the scales are tared and you're getting what you pay for, and so much work in between. But we also, in my mind, have the responsibility to become an agency relevant to the challenges of the 21st century and make sure that the ways we're investing in our agency support you all and our communities across the state who are facing real and present challenges. So in the last 5 years, we've been focused in every corner of our department in scaling up and adapting programs to fit the needs we see coming out of the ag community. So for example, together with dozens of partners, conservation districts, farmers and ranchers, we launched the Colorado Soil Health Program to support voluntary incentive-based solutions to advancing soil health. We'll be talking about that. We've gone from $0 to $30 million for that work in fewer than 4 years. And that's thanks to so much of the work on the ground. We created an agricultural drought and climate resilience office that supports farmer and rancher-led stewardship to tackle climate change and invest in research and projects around renewable energy and innovations like agrivoltaics. We've been keenly focused on supporting the next generation, everything from investing in STEM education for middle schoolers to apprenticeships that are paid for up to a year, and a $20 million revolving loan fund for land access for young and beginning farmers, which is much of my background before I became commissioner. We've been focused on ag emergency response and response capacity, both before, during, and after a crisis. We've been hiring new marketing specialists because we know the foundation of this work is supporting businesses. We have climate marketing specialists connecting our climate work with new market access. We've invested millions in regional and local processing to help our food and ag businesses diversify and become more resilient. And we launched a new community food access program to help our families across the state and our small businesses and small farmers do more business together to help families feed themselves with safe, healthy, local food. We are responsible for foreign animal disease response and mitigation, and we've been beefing that up alongside our animal welfare work and focusing on prevention and education. And we've also created many new positions that are based in the communities we serve. One example is our regional assistant commissioner positions, very part-time roles on my senior team that represent their communities and represent CDA where they live. And then lastly, relevant to why we're here today, never until a few months ago has the Colorado Department of Ag had a person solely dedicated to water. And now we have our first ever Ag Water Policy Advisor, who is Mr. Robert Cicada, who you'll hear later today. So that leads me into our panel. We have an incredible amount of expertise, knowledge, and field-based work and history here with you today. And I'm going to invite each of our panelists up one at a time, And then we'll have time for some dialogue and hopefully lots of Q&A at the end. So I will do a quick introduction of everyone. We have Eric Whyte with us from the Ute Mountain Ute Tribe Farm and Ranch in Toyac. Greg Vlaming, also Montezuma County. Dr. Perry Cabot, who many of you know from his long work in research, and Greg Peterson with the Colorado Ag Water Alliance. So please help me in welcoming our first speaker for his presentation, Greg Vlaming.
Thanks, Kate, and thanks to Steve for including me. I'm honored and humbled to be up here. Again, I'm Greg Vlaming. I run my own consulting business focusing on soil and water conservation out of Lewis, Colorado, about 12 miles north of Cortez in Montezuma County. And the first project I'm going to highlight that we're working on is the CDA STAR program. Steve, are we having a problem here? Oops. There we go. Thanks. The STAR program originated in Illinois, I think, and is gaining a lot of traction across the West. We started it, we're in the third year this year in Colorado. It's a statewide program that is administered by Kate's soil health team with the CDA. The beauty of this program for soil geeks like myself and many others in the room is that it recognizes soil not as a benign medium, but as a living resource, okay? So it incentivizes soil health for growers, and we know that there's a very linear relationship between healthier soils and increased water holding capacity. And so it's very relevant to water and building resiliency in our systems, in our climatic extremes. This particular project is not a huge amount of money for our growers, but it's a paradigm shift in that we start to think about soil health when we make management decisions. And so it starts the conversation. It's a teachable learning moment that I get to have with the growers about, to incentivize them to change maybe how they're doing things to build healthier soils. This particular project in its final year this year pays up to $75 an acre, up to 66 acres, which maxes out at $5,000. Again, not a huge amount of money, but it starts the conversation in shifting, the paradigm shift. So the project is based on 5 soil health principles. Soil armor being the first one. We'd like to leave residue in the field to trap winter moisture, minimize wind erosion, minimize surface runoff. So if we can use a no-till seed drill such as this 30-foot job to seed into with crops, we can achieve leaving more organic matter in the field, leaving carbon in the field, feeding soil microbes, and minimizing erosion. We don't want to clean till any fields any more than we have to, as a basic premise. Minimizing disturbance is the second principle that we honor in this program. And this is a grower out in Pleasant View, Colorado, that has a triple gang swather to minimize passes across the field and get more work done in one pass, minimizing compaction. Continual live root. Perennial cropping systems that are so common in our area, particularly alfalfa in this picture in the Dove Creek area, is a great way. Soil health and soil microbes are fed by a continual living root and the rhizosphere around the root and the carbon that is stored through the plant photosynthesizing. This particular field is going to be shifting into another project that I'll be getting into here in just a minute. That's Michael Fury, a great grower out in the Dove Creek area. Plant diversity is another one. We like to see various species of plants with various rooting characteristics. Okay, so we have legumes. In this picture, we have clover, alfalfa, looks like some timothy, and some other grasses. So various rooting depths, various rooting characteristics, a legume which fixes soil nitrogen. And finally, the fifth and final soil principle for this program is livestock integration. We know that we can achieve nutrient cycling through running cows through our field. And this is on my particular farm in Lewis. And I know that my first cutting of hay the following year after a heavy grazing event results in higher quality hay and is part of my nutrient management program. This plus humate and compost is my entire nutrient management program. So these are the 5 principles that we're paying, that we're incentivizing our growers to do. In my particular case, and I know that High Desert and Mancos Conservation District in my area is also administering this program, but I'm working with the Dolores Water Conservancy District starting again in 22, and we're finishing this year in 24. We're on the Dolores McPhee project, so these are full service area irrigators. They're all large scale, mostly center pivot and or side roll. Everybody is sprinkler irrigated up there to participate in the project, but what we do know with our junior rights is their water levels fluctuate from year to year. A couple of years ago they had just over 2 inches of water. Last year we were 20 plus. So again, we want to build resiliency into our system so that by building soil health and increasing water holding capacity, we can maybe weather the low water years a little better. Maxed out the program in my area with 10 cooperators, 66 acres per cooperator, so it's over 660 acres, but in reality, 66 acres is about half a pivot. Most of the pivots in our area are 120 to 130 acres, and most of these growers did the same management decision-making efforts on the whole pivot. And so in reality, the project touched probably 1,200 acres in our area. And at the end of 3 years, resulted in over $250,000 in incentive payments and in capacity payments coming into our system just through our efforts on this one. Additionally, the Star Plus provided an equipment grant in the first year, and so each entity and or conservation district got $25,000 up front to buy soil health type equipment. And in my case, it resulted in drag harrows and brush hogs to mow down vegetative matter and leave the carbon in the soil. Weed whackers, we've got a certified seed grower in our area, SWCD, and so instead of going out with a tractor and chemicals, we got them some battery-powered weed whackers to go out and rogue out the weeds in their field, and again, minimizing compaction, so we check a box that way. The other piece was, in this particular picture, that 30-foot no-till drill, there was some residual money in the program that was, I think, more of a competitive bid process. The program ended up paying about $40,000 towards buying that no-till drill so we could seed into that kind of soil armor. So this project makes real differences. It's really been terrific, and I can't say enough about it. We'll talk about climate smart commodities in a minute because it's a continuation of the program. This is the intrepid Michael Vicente. He is the irrigation manager at the Ute Mountain Tribal Farm and Ranch Enterprise in Toyoak. And this program, the STAR program, also included soil moisture sensing equipment in every field that's participating in the program. And what this sensor does is it measures soil moisture at 6 and 12 inches. So I put these in every field, and I build a fence around the fields where they're going to incorporate livestock integration so the cows don't wipe it out. And then Michael, in his ingenuity, wrapped some pink flagging around that so it didn't get bound up in the swath or in the combine. Now, this field was in corn originally, so that thing was virtually invisible to equipment operators out there. It looks like they just got the oats up in this photo. And this is the graph from that soil moisture sensor, and this tool has been invaluable in working with the growers and showing them how their irrigation is working for them. There's 2 lines in this graph. The darker blue is 12-inch soil moisture, and the lighter blue is 6-inch soil moisture. And so they can see how they're doing. You know, a lot of these guys run by the seat of their parents' experience or intuition, and this quantifies it. Okay, the yellow area, quick soil physics 101. The ideal soil is about 50% mineral and 50% pore space. And that pore space is where the air and water fractions fluctuate, right? We get a big rain, the water level goes up, we get a drought, and the water level clearly goes down. So ideally, we stay in the 25 to 30% range on water as the ideal, what we shoot for. That would be represented by the green portion of the graph. The yellow part is above field capacity. That's considered saturation. That water is not available for uptake. And in the red part is below permanent wilting point. Again, the water is bound tightly in the soils, plants can't take it off. So you look at this graph, and I show this to a grower, and I say, well, it looks like after September, you must have gone on vacation or something, because we drop off dramatically, and then we kick it back up. What happened, and how do we mitigate that in the future? So this has been a great tool in the STAR Plus program. Starting this year, the Climate Smart Commodities program is another soil health program that is fashioned after the STAR Plus program. Same sort of 5 soil health principles, another pot of money that is going to be a continuation. This particular program, I'm working just only with the Ute Mountain Tribal Farm and Ranch Enterprise. Simon Martinez and Eric and Michael and Von Cook, the agronomist out there. We've got 10 fields, again, the max, 660 acres, but again, it'll be more like 1,200 acres, and it'll pay over the course of 4 years, $275,000. They also will get soil moisture sensing. They will also get start of project and end of project soil testing that we can consult with them on. To see measurable changes in soil quality, it takes more than 3 years, but we can just start on the path now. And then I'll just talk about a few more projects before I sit down. With Dolores Water Conservancy District and Basin Roundtable, we were funded through CWCB and WSRF for a center pivot overhaul. A lot of the full-service irrigators, when that project was built in the 80s and early 90s, still has the original equipment out there. A lot of the center pivots and side rolls have worn nozzles, worn out pressure regulators, worn out seals, gaskets, etc. So what this project is funding is a center, what I call a center pivot overhaul. Producers provide a 20% match, and we'll pay up to $5,000 for them to swap out nozzles, swap out pressure regulators, and any other application efficiency upgrades that they can do. This is another one of these graphs that I talked about earlier. This grower swapped out his nozzles and pressure regulators before September 1. And you can see where he is on the 12-inch depth soil moisture. He's in the dry zone. He's too dry. And he's doing okay at 6 inches, but once he swapped the nozzles out, we immediately see an application efficiency upgrade. The water's going further. He's maintaining more in the water, the plant available water fraction of the soil, even nudging up on the high side. So again, this project is going to increase our water use application efficiency greatly. The UCRC SCPP project, we just got approved recently, and contracts are being administered right now. I've got 9 producers on about 800 acres participating in the project. And what this project really does is it incentivizes reducing consumptive use. And what that means to a lot of our alfalfa growers is we're going to grow a different crop. We know that the alfalfa market is waning a little bit as well. Dairies are either consolidating or going out of business. The anecdotal conversations being had by the growers in our meetings is that the market is going down. And so we need to find alternative cropping systems, forage crops, grain crops, but things that also have a reduced consumptive use. So by exploring these other markets and reducing their consumptive use, this project incentivizes that water savings. And that's water savings that stays as carryover in our basin as well. It's not being shepherded downstream. But we're getting, this year through this generous project for 9 producers, we'll realize estimated over $420,000 for growers. And finally, I'm not going to jump Greg Peterson's drama too much here, but the Drought Resiliency Project is another chance to talk about soil health. He's reducing consumptive use through his cropping system incentivizations. And what I do as I administer this project is say, okay, if we're going from perennial crops to annual crops, we have a lot of opportunity to administer the 5 soil health principles wherever possible. So again, this is another well-funded project. We'll have over 950 acres involved in it, and to the tune of about $190,000 for my growers. And finally, we'll do questions at the end. Thank you.
Thank you, Greg. Now please join me in welcoming our next speaker, Dr. Perry Cabot from CSU.
Hey everybody, thanks for giving me a few minutes here to talk about this set of projects we do at the Agricultural Experiment Station for CSU, and I'm looking forward to a good discussion with our panelists. So being that the topic provided was innovations in agriculture, I thought I'd just go through a subset of projects that we do at the Agricultural Experiment Station. Some of you may know this, but I'm part of the Agricultural Experiment Station unit for Colorado State University. That's essentially a sort of an engagement / research arm of CSU, but we're based in the Grand Valley. So Director Richard is actually here somewhere, and she oversees all 3 of the research stations, and I'm based at the one that's primarily focused on water and row cropping. And of course, like any good academic, I have 15 different, partners I have to acknowledge here from all these different colleges, but what I just explained to you is sort of the team that we have working on all this. Bottom one, that's the right one there. What I'm going to go over real quickly is how we have approached the issue of innovation. And so I'm going to cover 3 different areas: the irrigation technology that we work on, consumptive use, estimation and modeling, and alternative cropping systems. So you can sort of think of this as if the goal is to innovate for the purpose of more water in the river, more optimal water use across the agricultural landscape, minimizing what we're actually applying for whatever reason we choose to do that for, to make sure the farmer stays whole, while at the same time optimizing water use. So what's going in is really important. What's coming out is important. We do a lot of alternative cropping systems to look at possible more profitable or equally profitable crops, combined with water leasing scenarios that reduce the amount of water leaving the field. So in, out, versus how do we actually measure that? And that's where the consumptive use modeling comes in. Some of you may have read the work that Shannon Mullane has been publishing for us in the Colorado Sun. And this is a far too complex topic that I probably wouldn't do justice to even if I had the time. But what I can tell you is that artificial intelligence, which of course everybody knows is sort of the new in vogue type of research area, has made its way into sustainable agricultural water management. And the point I like to make in this descriptive pathway here is that we have an abundance of information, obviously, about how to grow things. The sensors were discussed earlier, how you actually grab the data that we need to have in order to make management decisions, basically about the crop that we're looking at. And that could be anything from moisture sensors to UAVs and things I'll talk about in a second. So along this pathway, we are really good at producing the data and processing that to get to where we can actually have platforms that we can look at. Where we tend to get hung up these days is in the decision making. So we like to think we're being data-driven decision makers, and most farmers are, of course, because they have experience with their property and their land and the history. And so their eyeballs and their fingers and everything else, these are the sensors that allow them to make good decisions. What we know now is there are other ways to gather that kind of data. Sensors were mentioned earlier, but now through remote sensing or UAV-based spectral signatures and other ways that we can effectively measure color and other visual cues as well as biophysical cues. We've got more data coming at us than we really know what to do with. So that's kind of the point, is there's so much we're just getting bombarded with all this, and so we're kind of high-centered in this area of how do we make use of all that? And this is where AI comes in. And AI and machine learning are sort of machine learning is kind of a subset of AI, which I should mention that's a part of what we're doing as well, in order to get to the point where we can actually make decisions and then ultimately benefit our crops. So this area of AI is where we're using some of the newer tools in order to make decisions about our kind of irrigation at the research center. So I contrasted, or I made this point about AI and machine learning, and AI is essentially this kind of, the scary part of it is this unsupervised learning brain that's going to tell us all these things, and we're not doing that. Machine learning is really where we are in this pathway, which is essentially using data that we already have to train models that then we verify against other data that we already have. And when I say modeling, I'm talking about spatial models and linear models and other ways that we can make use of all this huge volume of data. And in order to, this is the sort of centroid of all these different things that we can now do with these essentially robots, things that can be out in the field for us. This one is one of the more fascinating ones, and I don't know how many of you have entered into drone work, but we started using UAV-based herbicide application, and it really works very well. I mean, they're still working on payloads for these things, but I mean, we're getting up into 10-gallon, and they're basically helicopters at some point that don't have pilots. But for our smaller field sizes and some of the producers that we work with, we can use those sorts of tools. And so the question is, if we have this precision tool, where's the best place to put it? Previously we spray across the whole field because that's the nature of the beast. And now we can get visual cues that allow that drone to kind of make its own, not make its own decisions, but we can set a pathway where it can be and hover and get herbicide where we want, and maybe in places we don't need it. So that's one of the more fascinating ones. Some of this plant health identification stuff is being done at other universities. Weed location is a really exciting area because weeds have different residence times, and they have different locations where they occupy different spaces in the field. So that's a way that we can figure out where we actually might need to optimize our drone work. Thanks to the Colorado River District, we were able to purchase a linear move irrigation system, and that got constructed last year. And so we're using that system in order to irrigate a 12-acre field at our research station. I'll just point out that every 4 nozzles on this system has an actuated valve on it, so it allows us to do variable rate irrigation. And my point in telling you all this is not to sort of whiz-bang you with all these things that the research station does, but to take you to where we think, again, and this could also be applied to a center pivot, but where we can actually begin to use some of the prescriptive tools that would allow this system and others like it to irrigate in accordance with a spatial prescription, not just push the button, put on 1 inch. And I should add that this is coupled with our timing with soil moisture sensors that will go in the ground as well. So, and this, here's our sensor network that we basically gather a lot of static data about the field. And that's all in-field stuff, but where it gets really exciting is where we can start using our drone to map the spectral signature of what's going on with the crops. And the reason why that's important is because, the sensors are out there. We can get good data out, from the sensors, and we've got probably more out there than we really need. And that signal can be compromised at some time due to plant height and other things, and there's technology that's helping us get around that. But it's never going to be as resolute as something like an NDVI map, where this is, we're down to sub-centimeter level measurement of plant leaves and things like that. So we can do that all the time and then assign an action against what we're trying to change on this field. This is a cornfield, and so you can obviously see intuitively green. We have better yields in some parts of the field than others, all planted at the same time. That then is contrasted with the thing that everybody cares about, of course, is the yields. So here's our yield. This is actually a year that we did, we were furrow irrigating, and we did pretty well on some of the yields there, but it's furrow irrigated, so we weren't as optimal with the data as we could. This past year, we were able to analyze this same field and determine that, as can even be seen here, that down in this area, we do have higher organic matter. So some of the regenerative health or regenerative ag people are going to be pleased to hear that we have higher organic matter, slightly higher water holding capacity, a little less over here. And so the point is how do we take all this information and actuate it? What do we do with it? Well, that's where something like this irrigation prescription tool comes in. So with a VRI system, the producer is, of course, not going to, this is basically anybody operating a system with this level of precision, is not going to be able to go out and describe, I need 0.8 inches here and 1 inch there. And I mean, it would be probably a lot of educated guessing going on. But the AI learning models and the training models that relate that NDVI color to the crop yields ongoing every year, that can start to train us when we need to irrigate and at what rates, with the sensor data, of course, coming back, and even some of the underlying soil moisture data underneath. So we've got this kind of sandwich of all these data layers that culminate in a way that we can optimize our water use and at the same time try to maximize our yields. And that ends up looking like this in the Renke. This happens to be the Renke VRI tool, where the producer or the AI model itself would assign a different percentage rate, so 100% ET for that given cell, and then lesser percents for other cells where it may not need that water. So the clay holds water better. Maybe when the thing walks back over, you don't need to supply as much water to the clay because it's already got the water there. Sand holds less. Maybe that's where we actually we need to put more water on. So we're not applying water where we don't need water and causing all the problems associated with erosion and what comes with that. I decided to skip that slide because it was just we got a time constraint here. But this is drone work is what I mentioned, and so this is a really exciting entry point into some of this work that we can do at the Agricultural Experiment Station. We've recently acquired this kind of a drone here, which that little sensor there costs more than the drone itself. And what that does for us is it measures temperature. So temperature is a really important component of evapotranspiration for reasons I'm sure you can intuitively understand. We can measure temperature of what it's looking at 10 centimeter scale. And that's really exciting because it allows us to take the step into the detail and level of mapping that you're seeing right here on this. This is an almond grove that's actually this is down in Arizona, I think. Where contrasted with the Landsat data, which many of you have now kind of been exposed to through OpenET, you can totally see the difference in the resolution of it's obvious. So now with this level of data, we can measure consumptive use. I shouldn't say measure, we estimate consumptive use and model consumptive use at very, very detailed scales. And get to the question that so many of us want to know, which is how much water, are we? We have a lot of good models that are weather-based and coefficient-based, but this is actual ET. How much water are we actually using within about a 5 to 10% accuracy on all these crops that we're looking at? Now, I only have one drone, so I can't, we can't be all over the place, but hopefully we're going to get into some training around how to use these tools. We have 2 graduate students working on some of the models that we're going to apply. One of them is actually the metric model, which is used in the OpenET platform. And so as we enter into deficit irrigation arrangements and different alternative cropping systems, we will have the ability at the research station. This year we're embarking on, I also don't want to step on Jeff's or Greg's talk because we're doing some of the alternative cropping systems, but we'll be able to measure some of those. And so I'm excited to work with Jeff on ET rates for alternative cropping. So there's a nice little tech advancement. And I already made the point then, so as we grow these alternative crops and try to contrast them with what's traditionally grown, alfalfa, corn, other things, we'll be able to understand the different consumptive use rates and consequently how much water is being conserved. Likewise, I have a lot of producers that are interested in knowing the trade-off between ET and residue cover, E and T, so that'll be an opening point. And the last thing I'll say is that the really exciting area of work for me is this area looking at winter cropping, winter pulses. So those winter pulses give us the ability to grow things outside of the traditional hot growing season. And we even have some producers doing this in the SCPP. It's a way to kind of maximize soil health and provide possibly an edible human consumption crop, and at the same time maintain a nice cover and basically grow something out there instead of just shutting down the whole operation. I'm going to go ahead and just turn it over then to the next speaker. Thanks. I'm sorry, I didn't know that.
Great, thank you, Perry. Up next, we have Greg Peterson, Executive Director of the Colorado Ag Water Alliance. Welcome, Greg.
All right, well, thank you so much. And Steve, thank you for inviting me here. I really appreciate it. So I'll get to that picture in just a minute. I think it was 2 weeks ago I got an email asking me, can you please send us the addresses of all the farmers you work with? I'm working with students, and we want to have them write letters to encourage them to grow crops that use less water. I'm still trying to think of how to, I'm preparing for that conversation, how to tactfully handle that. And so this is my dry run of that, and we're going to see how it goes. But it was a good email because it reminds me of something that I think a lot of people out there, they're like, well, why aren't they growing crops that use less water? Why are they growing alfalfa, which is an amazing crop? But, I mean, Eric, are you all can you rip out all your alfalfa at the Ute Farm and Ranch? I've got some cactus fruit. Uses very little water. Greg, Peter, or Greg, Perry, do you guys have, none of your farmers you work with want to grow cactus fruit? There's no shortage of produce, grains out there that use very little water. You'll find tons of these studies, stuff like cactus fruit, things that I can barely pronounce, like jojoba, which is used to make oil. But this is not an easy question. And honestly, I wish I could say, when we talk about the issue of alternative crops right now, I said, okay, we got guys out in the hallway with contracts for an alternative crop that uses less water and that's profitable. Go at them. Start signing up. And that's not where we're at right now. But I'm going to get into that, just a little bit of where we are. So, it's been 7 years now since I worked on this project with Brad Udall out of the Colorado Water Center. And I got an education in alternative crops. And we pretty much did this deep dive into what's the history of people trying to do large-scale crop shifting in the American West. It ain't pretty. You really have two examples of successful examples. One on the Verde River in Arizona, and trust me, you want to call it the Verde when they're around, not the Verde. And then also over in the Walker Basin in Nevada. And outside of that, though, this is incredibly difficult to pull off for a number of reasons, and especially at scale. But before I guess I need to mention, though, that for years, though, all throughout the state of Colorado, I mean, you do have farmers switching crops based on water availability. Whether it can be on a yearly basis, it can be on a more long-term basis, whether it's from corn to milo, sorghum. In the San Luis Valley, you have a lot of people growing potatoes for market and then growing potatoes for seed. These are shifts that are always happening every year. And often they're a response to limited supplies. But really, there's very few successful cases. And we can ask Eric, we can ask the farmers that Perry and Greg work with to grow crops, and they can. In 2018, we grew a lot of hemp. Couldn't sell that much of it, but we grew a lot of hemp as a state. And that's just one part of this value chain. And it takes years and years to really develop these new crops, these new industries. And it has to be economical. They could all grow oats. I don't think they're going to be in business that much longer. And really, when you're talking about switching crops, you're talking about a lot of other changes that they have to make. Whether it's equipment, almost every different crop, different kind of equipment, and that's not cheap. Labor. I know we're talking about water, but if you think water's the biggest problem in ag, it's not. It's labor. And especially after the ag workers bill that we had in Colorado, I know more farmers getting out of labor-intensive crops. So that's something else you have to think about. What about the climate? What about, is there a processing facility? Last week I was with a farmer in the Grand Valley up near Grand Junction, and he's growing wheat. And he pretty much breaks even because the shipping cost to Denver almost takes away his entire profit. And he's really just using it as a filler between alfalfa crops. And so these are things that you really have to consider when you're trying to do this, that makes it much more difficult to actually find alternative crops that are out there. And I think you've got a really good history, though, of how to do this. And we have examples. We even have, one recent example is Colorado Mills over in Lamar, Colorado. And they've been working with a lot of farmers in that area growing sunflowers for sunflower oil. Uses less water. That wasn't the intent. But when you talk to them, they're like, whew, those first 5 years were rough. They're not paying based on yield. They're paying based on acre. Because, they need to, these farmers, they needed to keep them whole and essentially spend 5, 6, 7 years showing them how to grow sunflower seeds. And this is the model that Great Western Sugar used. When Great Western Sugar used to come into a town, they're bringing agronomists, they're bringing equipment, they're showing you how to do this. And if you're not doing that, you're wasting everybody's time. If you're just going to say, hey, all of you, let's go grow some Kernza, but you figure it out. Good luck. You're just wasting everybody's time and money on this. And I think this is something that we're really starting to learn here in the state is how do we support people trying out these crops? And that can mean a lot of different things. And so, like I said, I wish I could tell. I'm not going to be up here standing and telling you, here's the crop, here's how much per acre, and here's how much water you use. We're not there yet. And instead, I'm going to be talking about really the people and how we're able to support them. And at times, that support is, every time that support is either technical or financial. But it's really a story of just pioneers. And trust me, I realize the irony of this slide right here on the Southern Ute Reservation, and it's going to get more ironic with the next slide, of just people who are going out there and willing to try and experiment with crops that they've never grown before. And that first group, and I think I'm not going to say too much because I think Eric's going to get into this, is just with Eric and Michael and Simon, who I didn't see him. Simon's not here today. Was on the phone with him yesterday in a meeting where out on the Ute Mountain Ute Farm and Ranch, they're growing Kernza, sandfoin, a perennial legume. And essentially, we're just starting the second year of that, learning a lot how to do some weed control too is one thing that we're trying to figure out. Essentially, we're asking these people, how do we grow this? We don't know. We can't tell you planting dates exactly. We don't know what kind of herbicide or pesticide to use with this. You got to figure that out. That's a huge financial risk for these people. Essentially, this project is covering everything financially. Otherwise, if we did not do that, they wouldn't experiment with this. And that's totally understandable. That is the level of support that you have to give if you're willing to let these people experiment, especially in this part of the state where, last year was a good year, but the 2 years before that were just brutal for the full-service farmers on the Dolores Project and the Ute Mountain Ute Farm and Ranch in terms of water allocation. This other gentleman here, Dan Hobbs over in Cortez, another project, and he's, last year he did, I think, 50 varieties of small grains and legumes and testing those out in trials, and this year he's got about, I think, 7 or 8 of them that he's going to be contracting with local farmers to just bulk up on that seed supply for Pueblo Seed and Food Company. And just like Ute Mountain Ute Farm and Ranch, they have the ability to process and ship this product, which is really key for all of this to work. Another guy, that's Troy. That's his grandson, not his son. Him and Calvin, they farm up in Grand Valley. Is anybody? Perry can't answer, but does anybody know what plant that is? Oh, okay. Camelina. Thank you, Gigi. Yes. So Troy is a certified seed grower in that area, and he's growing camelina seed. And he was approached by BP and Exxon to grow, to be their certified seed grower for camelina. And they're taking a pretty big risk this year. I think they're about a 1,600 acre farm. And I think this year they have about 240 acres in camelina. And again, it's, how do you grow this? He is planting different dates, trying to figure out different times, different varieties, different planting widths. For this project, how we helped out Troy is, I mean, if you've ever seen camelina seed, it's incredibly small. He had to retrofit his combines. That's about, I think it was about a $7,000 project to retrofit each combine to be able to handle that seed. And so again, that different equipment. And we're really curious. We know that this can use less water. We're just trying to figure out how profitable can it be? How does it work with his other rotations? And just really, how do you grow this stuff? What are the planting dates? And really glad that Troy's taken that and that we can support him with that project. This is Chuck Hannigan. He's one of those melon growers out there in the Rocky Ford area. And a project that he has this year is cowpeas. And out on the Eastern Plains, actually, you have quite a few people experimenting with this crop, whether it's with forage or for direct human consumption. And here, again, what does it take to get someone to experiment? We're paying him a flat rate per acre. So that way, if he has a total crop failure, that this isn't a liability for his farm. Again, that's the risk that we have to take. Another grower, Brad Haynes, he's up in Logan County. He's growing cowpeas, black-eyed peas for human consumption in a dryland setting. And up there, I mean, northeastern Colorado, a lot of hail, and he can't get it insured unless if he's been growing it for 3 years. So it's this odd chicken and the egg. Well, do I grow it and take the risk? And essentially, we're helping him out with that cost so that he can get that growing history and then insure that. And then this is Sarah Jones. She's over in the San Luis Valley. She farms with her family, her husband Mike and their kids. And that's rye. So some people might be familiar with that. They use it a lot in the San Luis Valley, really as a cover crop on fields to just really hold the soil together to their winds that they've got there that can get pretty brutal. And the past 5-10 years, the Jones family, they've been, they're not just growing rye as a cover crop, but they're processing it, a lot of other small grains, and using that and a lot for distillers, other companies. They've really developed those connections. And what's really exciting is the past year, they're getting 10 of their neighbors involved in growing rye for distillers. And essentially what they asked the Water Conservation Board to do was provide them a grant to subsidize and say, our growers need this at 40 cents a pound for us to be able to do this. And we need to grow a certain volume so that we can actually start making contracts with an end user. And that is not a traditional grant ask, but really and every one of these projects, the Water Conservation Board has really been a big help with that. And this will be last one. That's Paul Bruchet. He's a rancher up in Kremling area. And him and his family and his neighbors and what they've been doing for the past few years now is, they're irrigated hay meadows, they're literally ripping out their grass with some pretty heavy equipment, power strippers, power harrows, and replanting different kinds of warm season grasses, kernza, sandfoin, silphium, bird's foot trefoil. And they're really seeing reductions in their water use. Perry knows these numbers a lot better than I do, and they're getting better yields. But you're talking ranchers who hay, and they're using equipment that honestly, they're the only ones in the county that have that kind of equipment. And so this is where we're at with alternative crops. I don't have somebody with a contract out in the hallway, but if you're willing to try, we can find the resources to really support you. All right, thank you.
Thank you, Greg. And last but not least, Eric Whyte, the hay manager from the Ute Mountain Ute Farm and Ranch Enterprise. Welcome, Eric.
Well, thank you all. Thank you all. Now, who would ever want to be a rancher and farmer? Are you kidding me? It doesn't seem like there's a lot of future into this. But also when the water project kind of came into fruition and for what we had for the tribe, the main thing was domestic water supply. And again, there's a lot more good partners that we have within the audience. And I've got to see quite a few of them that also started with the tribe a long time ago. And for me, that was about 32 years ago. Again, this project has been in the works for quite some time, but seeing that kind of develop and where that is, we got to put all these pieces together, all this technology, this information, how does that apply? How do we put that together? And again, it's been a really good journey. It's part of this book, and a lot of people talk about history. This is another part of that history in the Ute tribe. And I know one of the individuals, or a lot of them, they always prefix you, and I hear this a lot. Even our chairman, Manuel, had mentioned, he goes, we're not farmers. And I hear that so many times, then why are we trying to do this? And it reminds me of my boys when I talk about this, and it's a little Finding Nemo part, and they're all trying to get out of that aquarium. Let's get here, yes, here, then we'll be able to be free. They finally get out, but they're in that plastic bag, and they get to the ocean. Now what? So now we're putting that now what together and developing that and making everything quick. So I hope there'll be some questions. And again, there's some solutions to these questions, and we want to be them problem solvers. And when you talk about some of that new generation or other crops that don't use this much water, it's kind of one of them things. We're going to utilize this, but we want to see. You're not going to see any pictures of that, because I know how ugly that looked, and I don't want to see that up there. And again, we had other people that came out and helped us along the way and prefixed these, and they come out and look at it, and it's like, man, this is not where I want to be at. I don't want to show you that, but let us show us what the capabilities of this is. So as we go forward, this is one of the good years, and we talk about different crops, and this is one section of that area. This is our 1,000 block. You can see the headquarters in that upper left or lower left-hand corner. But this is probably a good year. We didn't have to worry about water. The lake was full, and just like how Becky mentioned, it's easier to negotiate. But having to make this work, and you see that land is surrounding, you had to build up that fertility. You had to have some parts to hold that together. When you talk about virgin soil, it is really important to try to make that happen. So you had to have that little bit of mass. So again, when we started, we planted some wheat. And getting that kind of going, this is one thing that most people, and you like to be the first at a lot of things, and that's kind of cool. But when it came down to developing this farm, being the first at what we were going to do and put that in the ground, I can honestly say, for the time put in, I was the first one to put the first seeds in the ground when this came to fruition. Again, there's a lot of good people that were working at this and keeping that drive alive. So again, when you look at this, you see some of the wheat, you see some of and we talk about sunflowers. Again, there's a part of that there, but they're good pollinators, but you don't have enough pollinators out there, so we had to go get some bees. And along with them bees and having to do that with, you got to worry about the other wildlife. We found some bears that love that honey, so they were knocking down the hives and stuff, so we had to set them back up. You know, everything that kind of comes with it, you have a good plan, but there's other outside entities, other problems, other issues that come along, and you work with them. And working with a group, and you talk about labor intensive, them are things that were really pretty labor. We went and looked for a lot of different individuals within the tribe, but also in the county. And we hired and brought everybody else because we had to do certain things to make that work. And so I worked the fields, went with them, and talked about bees. And I said, now with bees, you don't want to hurt them. When you do that, boy, do they let themselves know, and boy, they let everybody know. So one day, we had to get out of a field quickly and go away from that because they were swarming us pretty hot and heavy. So, and then when we talk about our partners, again, we have some very good partners. MVIC, that's one of them, Dolores Water Conservancy District. But you look at this reservoir, McPhee Reservoir, the Bureau of Reclamation also came into the fact that you do different things, but they were the ones that kind of helped put this project, make it more feasible, but also having it become to reality. Everybody has a plan, seeing that plan come together, and you see them pieces of the puzzle kind of coming along, and this is part of it. And the slides and pictures, I am not very good at computer, but they've kind of touched them up a little bit. And one thing with these cool things and stuff, they said, Eric, we're going to have you go out and go take some pictures. And I said, okay, we'll do that, but we're going to put you in a plane. I said, are you kidding me? Having to work in a small single engine and bring what you need into that, it was an adventure. But boy, what I got to see up there and see the county in different areas, farmers to the north, and see what the land that they had, but you see the city of Cortez growing also. So, I mean, a different view from a different side, and we were able to kind of do that. So we flew around back of the mountain in other parts, but I said, let's go a little bit south to go see where we live at. And again, from when you talk about the water and where it touches, it goes quite a ways. And so when we talk about the BOR and building that facility, we talk with 41 miles of line canal. Again, you're talking about innovation, what we had to do to go ahead and make that come to pass. And we talk about engineers. They have this engineering. We're going to make this go to move that water along the way. But also with that water being moved along the way, and again, once we started taking water, then and with the tribe and the legal part and within the words of the language, you got to understand that also. So with that, once we started taking water, there's always that repayment contract for the M&I water. So you got to be able to take care of the dam and the delivery system. As of the tribe, we pay well over 60% of that operation and maintenance costs. Well, when I say the tribe, again, I got to come down below that. The tribe pays a lot of that for the domestic water supply, so everybody can have a shower or use that for their lawn or different things. But how to come away from that, not having that, and able to do that, most of us take that for granted. We grew up where we didn't have that shower, we didn't have that bath. We had to go across the road to pick up and get water from our grandfather's area that are big tubs. So when that water kind of came, it was the work within good people within the tribe that helped that. Mike Preston and others, and Steve Harris and leadership in there, Ernest House Sr., Judy Knight Frank, we're going to make this come there. But that had to start somewhere. And also the Dolores Water Conservancy District, and also a good partner in Marshall Porter's dad. Again, they had to put all these players together. And did we agree on everything? Definitely not. So again, when you talk about this project and how that kind of gathered together, it's been pretty cool. So as we cruise along and you talk water usage, we went from a high flow regulator and sprinklers to more of a you would say, usable part. So we backed off our water usage. We look at that, some of that, but also these are the new pivots, and we did the spray pattern a little bit different, high volume corn. So I mean, it was all that technology, but how to apply that and utilize that. So, but also you have your beneficials, whether it's bugs that you're having to go spray or others. With the ladybugs, I love that because they're coming, but you know you have some other issues with them. There's our other army that helps us out with that. So. And again, when you talk about alfalfa, everybody's taking, it uses a lot of water. But with that repayment contract, we have that obligation to go ahead and do that. And that's just all farm and ranches. And that's the first thing we kind of do, under or over $500,000 every year, regardless if we get that water or not. So, I mean, there's a lot going against what we're trying to do and how this goes, but we try to innovate. We've updated how we bale our alfalfa and do different things. So within the alfalfa plant, not just the stems, but you gather and hold that leaves where the higher value. We do ship it to Texas because that's where some of the dairy markets are. But also we're looking at in some of the horse market people, and them horse people, everybody loves their horses. They pay a lot of good money. And when you talk about the cattle, this is a cow-calf operation, about 650 head. And you look at this, they come and graze at different parts during the summertime. When you talk about Hillsdale County, we get up in there and they go and up above the blue, but we come in and do that among the farm. So it's a pretty good set of cows. But how you do that, we use all that technology. When you talked about Temple Grandin and how it'd be more nice and gentler with the cows, this is one of the other aspects that we had. We just got this, and you could see how gentle it handles the cows, but also what we're doing in it goes along. And who wouldn't want to be a cow to sit there and look at that forage, what we have? Again, it's been pretty beautiful for them. Then some of the wheat that we've tried, different crops, and add in that crop rotation. In this past year, about 90% of our crop went right into Cortez milling. So when you talk about the bluebird flower, this is where this kind of went to. Because you cut down on labor, but also you're talking about freight costs. If we can use it locally, we do that quite a bit more. So this is one of them cool photos and stuff there. Again, when we talk about technology, I didn't touch on the terms of or sandfoot, but what we're trying to do is capture some of that energy that's kind of not used. And this is the high end of, you would say, something innovative. but the micro hydro plants that are going to be generating some electricity inline flow. So you're not losing that energy, you're actually putting it to use. And this is one of the processes there. And talk about a process and the individuals doing this, it's amazing work. And again, if we had to go ahead and go out there and do it ourselves and pay for it, it's probably not part of the plan. But we're working with other partners and stuff to make that go. So, I mean, we talk about the NRCS or other entities in there, but local markets, they really kind of help out here there. So when we talk about different people and how this works, you got to, and it's always an open invitation, come out and visit us on our side of the mountain. And again, this is one of the pictures that I had coming out of the school. And again, we're involved in a lot more other things, and this is a view from one of the high schools, well, the new high school that we have, that I was part of, which was really good. But every day when we kind of work out of this, you look at this and you thank God, we live in a beautiful country, but let me see the next day. So, thank you.
Well, panel, thank you so much for those presentations. So we have just around 10 minutes left in our panel and would love to open it up to questions from you all. So again, if you have a question, please stand up, raise your hand. There are folks with microphones who will be wandering around and bringing you a microphone to ask your question. So I'll open it to you all. Yes, right up front.
I'd like to ask if any of you have considered the work of Victor Schauberger from the early part of the century, who had demonstrated a lot of different various ways to deal with the pesticides, with soil health and well-being. He was a 7th generation forester, and if you haven't, I would strongly encourage you. His work, we literally have not caught up to what he was speaking to in his relation with our relatives, and it's very valuable information. And I think that could save a tremendous amount of money, time, and effort, and yield the kind of yields that we're looking for. So I just wanted to share that and encourage that. Thank you.
I don't think any of us are familiar with that. Would you please spell his last name?
It's Schauberger, so it's Victor, Viktor, and Schauberg, I think it is. I'm sorry, it's not quite as good if I'm not writing it down. But yeah, he gave a tremendous amount of information and speaks to a way to bring back the hymen to the soil, which brings back the electromagnetic field and the coolness and a lot of the things that we're dealing with, and his methods that he demonstrates. Also, he doesn't deal with bugs, and he shows that and gives prescriptions, gives demonstration of how to bring these things to fruition. So I would be grateful for any attention that you might give to that. Thank you.
Great, thank you. Other questions for our panel? Yes.
I'm curious, we read a lot in the lower basin about water rights being purchased from one area to be used by cities in another area, and that happens on the eastern side of the slopes. How is that, what's a water right worth for someone growing alfalfa? I mean, is there a metric that you guys use, and is there a market that people are trying to get at to equalize the usage of water by moving water rights, and do we have regulations within Colorado to keep them from going to Arizona, as an example?
Let me go ahead and answer that or speak to that. At times, that question always kind of comes up. You hear that from some of the lower basins because they want to kind of get some of that water. But for us and how we kind of do certain things on the farm, we had to deal without water for so long. And when it comes to that word conservation, it's one of them things that, man, we've conserved quite a bit, and we've seen that water flow by freely. Is there any compensation coming back that way for using some of that water that had done in the past? No, they don't want to say that. But also, we don't want to send anything down, but within these treaties or the water rights kind of setting, we have the other boards that work with us for MBIC in that water that was gathered in the storage. we want to be able to use that, but when in the language, you got to learn and how to read the language. And what that states is they have that obligation to go ahead and say, no, we want to use every bit of that water, whether we like to or send it downstream. It gets very difficult, and that's when you bring in the lawyers or other things. And again, you spend a lot of money working against that, where you're not actually using that water to work for you. So it's a good question.
Yeah, I just think just to add a bit onto that is water makes more value. Water generates more value in a municipal setting. It does. I mean, unless you're growing, I don't know what, in some areas in California where you have people growing almonds, they can really compete value-wise. And that's a really tough issue that we have, is that it makes more money to use in those settings, but we need food. There's all these other benefits that food provides and agriculture provides, open space, habitat, and that's a value we really don't attribute to it. For example, I guess there was a recent purchase of water over on the Eastern Plains, and on this ditch, the going rate per acre that farmers could pay is $6,000 an acre, and then water was allocated to each acre and based on shares. And local municipality paid 3 times that. And so it's really it makes it really tough of just actually keeping that resource in the community.
Great, thanks, Greg. Other questions? Yep, in the back.
In the first presentation from Greg, you mentioned the STAR program and how the demand for some of those soil health practices is really higher than the program was able to provide, like maybe on an order of 10 times as many acres that could be put under soil health practices. What do you see as the need for how to scale up the availability of either funding or other programs in order to see those soil health benefits on a larger scale?
I would defer this question to Kate.
Oh, I thought I was off the hook today, Greg. Thanks. Happy to take it. That's a great question. So the bulk, I mentioned we went from 0 to 30 million. The bulk of that 30 million is the 25 million Climate Smart Commodities grant that Greg mentioned that came through the USDA and is one-time funding. And so we've been in this era the last few years, coming out of COVID, recovery dollars through state and federal governments and local governments to really make these one-time investments. And I think we were successful in receiving that grant because we had already created a soil health program to receive money like that and had the network of partners and practitioners on the ground. So it is an open question of where we go from here. We're not expecting, certainly at the state level, that kind of funding. We are in a Farm Bill extension, so there's lots of discussion about Farm Bill appropriations that are not one-time, that are ongoing funding, and this is a huge priority for me personally and for our administration, that we see this funding retained in ongoing appropriations through the federal Farm Bill as well. Oh, yeah, Greg. Might have to just use another one.
Yeah, I've been thinking about just who else can help leverage these as we scale up. I mean, I'm a small fish in this water world and trying to do stuff, and there's only so much like we can accomplish, I feel like. And one of the biggest fish that I think we're trying to work with better and figure out is NRCS. And I think I'll say a good thing about NRCS, and then I have to bounce it out, is, I mean, I feel like they have their hands tied behind their backs, and they put out more money than all of us combined still. I mean, you talk about, I mean, single counties get $10 million a year in investments from them. And it's just, how can we work with those programs and that agency that's really struggling? And I just imagine how well it would work if they had their hands untied, if we were able to work with their staff shortages better, because we can only do so much without them.
We have time for maybe 1 or 2 more questions. Yeah.
My question pertains to switching to crops that take less water. And the question I have is, how much effort or have you had to be able to develop markets for this, because a lot of the crops you mentioned, most of us are not familiar with. And I do think that's the key thing as a farmer and rancher. We have to try to make a living at it. And when we're trying to move over to that, then we need to have somebody out there developing a market for us for whatever we can produce. Thank you.
Yeah, and Perry, I'll jabber while you think of a better answer on this. So, I mean, some of these, I think the easy ones are, well, what are the crops where the end user is livestock? I mean, that's the easiest switch to make, is there we have our end consumer. But really with a lot of these examples, you've had these individuals who've just spent years building those markets themselves. And that's where there are a lot of opportunities out there, like the Specialty Crop Block Grant. There's the Economic Development Authority, where they're very interested in investing in the facilities. But I mean, I would feel more if I had a farmer who wanted to try an alternative crop or something, and there's one out there, okay. But if I'd feel more confident if it was someone who had the processing facility or a connection, because if we don't have that, we've got nothing. And that part, yeah, is a lot more difficult.
And I love this question because it's a paradigm of the work that we do at the research centers. I don't like to enter into studies that are purely exploratory. There's plenty of things I would love to grow that are just, I don't know what a jujube bean is, but sounds cool. I view much of the alternative cropping work that we do as a necessary interface with, like, for instance, the water leasing programs. The SCPP provided, funding, of course, for farmers to stop irrigating, and I viewed that as a sort of a lose, in some sense. I mean, it's obviously money changes hands, but nothing worse than seeing just this bare field, and then you spend all your money on herbicides, which is something that else we see happening. So I'm really excited when I see producers trying to use an alternative crop that may not be as profitable under traditional, as a one-for-one comparison. But when you factor in a water lease rate, and as I mentioned at the end, this winter cropping cycle is really exciting to me, because we see ourselves growing commercially comparable edible pea yields. Start getting into edible stuff, you're kind of at another another layer of funding or revenue. So I look at that alternative cropping scenarios as having to interface with some other kind of external funding source. It just doesn't work for me otherwise. I'll say that, and I'll say some of the forage work that we've looked at, that's kind of the same thing. People throw around the phrase drought tolerant. I mean, to me, that's a phrase that needs to get clarified a bit more. The way I look at it is, can we stress some of these Kernza sandfoin fields to the tune of 1 year? And will they rebound after 1 year instead of the 3 and the 4 that we see? And so the opportunity there to use some of that temporary, voluntary, compensated, lease funding to make that transition is really exciting for me. I will say that camelina seems to be on its way to becoming a jet fuel. That's pretty cool. And in fact, that particular farmer sits on my advisory committee, and I got a call out of the blue from a company in Argentina that wants to grow camelina in that country. And so that to me was the kind of, I was so excited to call Troy and say, hey, I think I got another customer for you. And so that's what I feel like there's often this misconception among the public even that farmers are market makers. Farmers are market takers. I mean, unless I really got the snake oil right here, we're gonna just change the world with that. I don't see that happening. It's like say there's no unicorns out there. The market taking side of it needs to always be front and center.
I might just make a clarification, Perry. On the SCPP, it's not a demand management that forces fallow fields. What it does do is pays for reduced consumptive use. So in the case of my examples, my growers are not fallowing. They are growing less thirsty crops than alfalfa. Okay, so there's a slight difference there. And the other thing to the market side, I had a call last year from an investment group out of Denver that said, do you have any 5-star growers down there that are growing wheat or a grain crop? Because we want to pay a premium for it and resell it as a, a regenerative crop that would attain a higher value. And the money they were talking about was a couple times what the current market was. So there is some value added there, potential going forward.
Well, thank you all so much. Time's up, but I hope you continue the conversation over lunch. Join me in giving a round of applause to our panel.
Yeah, I thought that was a great panel, and I appreciate Commissioner Greenberg taking the time to be with us today, so thank you. It's almost lunchtime, but not quite. We need another 5 minutes. We have a bit of a special presentation, and I'm going to ask Al Pfister to come up from the Upper San Juan Watershed Enhancement Partnership.
Lights are bright. Thanks, Steve. I'm here to, I'd say with bittersweet, to pay tribute to a lady that has done some great things in the state of Colorado for our water resources, Melly Whiting. I'm fortunate enough she lives in the same town I do, so get to take a little extra advantage of her skills. But those of you that do know her know, she's was Governor Paulus's appointee to the Interbasin Compact Committee. She served on the Southwest Basin Roundtable as the environmental rep for I don't know how many years. She's the legal counsel for Trout Unlimited. And, it's, to me, one of the most impressive things about her, yeah, she works for an organization that promotes trout, fisheries, whatever. But in the development of our stream management plan, integrated water management plan, she made sure that we were taking into account all the different users in our area, the Upper San Juan. I'll be talking a little bit more about that this afternoon, but I just wanted to ask Steve to give me a few minutes here. She's not here. She's getting ready, doing the last minute things. Her last day of working is this Friday. And then this summer, her and her husband will be moving to Spain. So we'll be losing a great asset, not just for the Southwest Basin, but for the entire state of Colorado. I don't know if any of you noticed, but on Dr. Cabot's slides, Melly's name was up there on some of the research she was doing. Her efforts in getting environmental and recreational considerations into the state water plan are incredible. So I know I'm forgetting some, but one other thing that, in talking to folks, is that her involvement in just water resource management was the inspiration for women to get into the field, kind of the women in water. Just that she served as a role model, spoke up and did things that, not a lot of people, be they male or female, would be able to do, let alone do it extremely well. So that just wanted to, most of you are probably aware of Melly anyhow, but I just wanted to give that special tribute to her and say thanks in an indirect way. When we celebrate her leaving at the beer party, we'll do it. I can relay that then, but I just wanted to say thanks to her, to this group, because I know a lot of you have worked with her, and she's had a tremendous impact on management of our water resources. So thank you.